Okay, this is our lecture number 3. Today we are going to see some definitions. In that, we will see one by one: amplitude, period, frequency, and phase of SHM. Okay. Now, first definition: amplitude. Here see amplitude, maximum displacement of a particle from mean position. Maximum displacement of a particle from mean position. Suppose we consider this is the path, then at mean position x equal to 0, x equal to plus a, right extreme, and x equal to minus a, this is the left extreme. Then if we write the equation x equal to a sine omega t plus alpha, then this quantity a we call it as a amplitude. That is, this is the maximum displacement of the particle from mean position, either on right side or on left side. X equal to plus a or x equal to minus a, here small a, this quantity represents the amplitude. Now we consider next definition: period. We denote by t, period of SHM denoted by t. It is time required to complete one oscillation. Time required to complete one oscillation. This is the definition of period. And another one definition can be given, that is, period is always reciprocal of frequency. T is equal to 1 upon n. Here you know x equal to a sine omega t plus alpha. This is the equation of SHM. Now we consider here, suppose this t be the time, we consider this is the displacement. Now we consider another one time, t plus 2 pi by omega. Suppose we consider t dash is equal to t plus 2 pi by omega. Or I will write here, that is after time, from starting from small t, we consider t plus 2 pi by omega. What is the displacement? We write here x equal to a sine, okay, into bracket omega. Instead of small t, we write here t plus 2 pi by omega plus alpha. And we solve this, x equal to a sine omega t plus 2 pi plus alpha, and therefore we get here only x equal to a sine omega t plus alpha. That means after this time, okay, 2 pi by omega, we come to the original position, and therefore this is the period. T is given by t equal to 2 pi by omega. This is the that is a formula for period. Now here you know, suppose I will write here omega equal to root k by m, and if we put this value here, then we get here t is equal to 2 pi upon root k by m, or t equal to 2 pi root m upon k. This is the new formula for period. That means t equal to given t equal to 2 pi omega, this is the formula for period, and also t equal to 2 pi root m upon k, this is the formula for period. And you see here, if we compare this formula with our suppose formula of simple pendulum period, t equal to 2 pi root l upon g, this is the period for simple pendulum. Then t same, 2 pi same, and under root we consider instead of l there is a m mass, and instead of g, which is acceleration due to gravity, there is a value k, that is spring constant. This is the similarity between different formulas for period. This is for period. Now we consider next definition 3. Frequency denoted by small n. Frequency denoted by small m. The number of complete oscillations, I will write here. The number of complete oscillations by a particle performing SHM in unit time. That means in 1 second of time, the number of complete oscillations performed by the particle is called as frequency, and also as like this, t equal to 1 upon n, I will write here n equal to 1 upon t. Frequency is also a reciprocal of period. And from this we can get here n equal to 1 upon t. Value of t is here 2 pi by omega, therefore I will write omega upon 2 pi. Or we can write here 1 upon 2 pi root k by m. This is the formula for frequency. See here, this is the formula for frequency, that is t n equal to omega upon 2 pi or 1 upon 2 pi root k by m. This is the formula for frequency. Now we consider next definition, that is phase of SHM. Fourth, phase of SHM. A quantity which describes the state of oscillation of particle performing SHM is called phase of SHM. That means we consider here omega t plus alpha. It describes the state of oscillation, and so we call it as a phase of SHM. And in this omega t plus alpha, this is the total phase. Okay, total phase. And in this we consider alpha, this is the initial phase. Or we call it as a epoch. Okay, these are the some definitions in case of SHM. I will revise again. Amplitude means maximum displacement of a particle from mean position. That means if you can, this is the SHM, path of the SHM. This is mean, x equal to 0, x equal to plus a right extreme, x equal to minus a left extreme, or x equal to a sin omega t plus alpha. In this a, small a, this quantity describes the amplitude. Now we consider second one, period t. It is time required to complete one oscillation. That means it is the time required to complete one oscillation. Then t also we can write here periodic time. Period is reciprocal of frequency, t equal to 1 upon n. Now we have to obtain its formula. See here, x equal to a sin omega t plus alpha. This is the original equation of SHM. Now after time, that means at time t dash, we write, instead of small t we write t dash equal to t plus 2 pi by omega. We put this value here. Then x equal to a sin omega as it is. Instead of t we write t dash, t plus 2 pi by omega plus alpha. X equal to a sin omega t plus 2 pi. This omega gets cancelled, plus alpha, and 2 pi we have added here. That means we come at x equal to a sin omega t plus alpha. That means after this much time, 2 pi by omega, we come to the original position. This is the periodic time. Therefore t equal to 2 pi by omega, and omega equal to, also you know, this is one formula. Again you know, omega equal to root k by m. Therefore t equal to 2 pi upon root k by m, or t equal to 2 pi root m upon k. This is the next formula for period. You have to remember all these formulas. Now we consider third definition, frequency denoted by small n. The number of complete oscillations by a particle performing SHM in unit time. In unit time, how much oscillations are performed by the particle? We call it as a frequency. And also, frequency is reciprocal of periodic time. N equal to 1 upon t, n equal to omega upon 2 pi. We put the value of omega from this here, root k by m. Therefore 1 upon 2 pi root k by m. This is the formula for frequency. Also here we get here, suppose n equal to omega upon 2 pi, same thing, and now we consider the fourth, phase of SHM, a quantity which describes the state of oscillation of particle performing SHM is called phase of SHM. That means if we consider this expression x equal to a sin omega t plus alpha, in that omega t plus alpha, this is the total phase, and alpha, this is the initial phase, we call it as a epoch. This is all about, that is amplitude, period, frequency and phase of SHM. Now we consider next article here. Maximum and minimum velocity. Maximum and minimum velocity. And again next we consider here maximum and minimum acceleration. We consider both the articles side by side. Maximum and minimum velocity, maximum and minimum acceleration. See here. Suppose we consider SHM. Suppose I will draw here. Suppose this is the path of SHM. This is mean position x equal to 0, x equal to plus a, and here x equal to minus a. See here. Now maximum and minimum velocity. You know the formula for velocity. V equal to plus or minus omega root a square minus x square. Now at mean position, x equal to 0, and therefore v equal to plus or minus omega root a square minus 0 square, means v equal to plus or minus omega root a square, or v is equal to minus or plus omega a, or minus or plus a omega, and this velocity we call it as a maximum velocity. That means when particle is at right extreme, then we get here x equal to plus a, we get a omega, minus a omega be the velocity, and x equal to minus a, we get plus a omega be the velocity. Minus and plus signs, that means here at extreme position we consider here, so sorry, this is for acceleration, we get here maximum velocity is a omega plus or minus. Here you see plus sign means particles going towards right, and minus sign for whenever particle going towards left. Depends on our that is a plus x axis minus x axis, that is x axis of our coordinate system, and suppose this is the origin, then plus a omega means the particle starts with maximum velocity from mean position towards right, minus a omega means particles crossing starting, that is going from mean position towards left with maximum velocity. This is the maximum velocity. Now at extreme position, what is that? Is we write x equal to plus or minus a, therefore v equal to plus or minus omega root a square, and put the value of x plus or minus a, then a square minus a square, we get here v equal to 0. This is the minimum velocity at extreme position. Here we got v equal to 0. This is minimum. V equal to 0. This is minimum. Okay, minimum v, and this is maximum v. Okay, I hope you all understand this. Now for maximum minimum acceleration, here you know acceleration is equal to minus omega square x. We consider first case. Here we have seen first and second, like that. At mean position, x equal to 0, and therefore acceleration is equal to minus omega square into 0, and which is equal to 0. This is the minimum acceleration. At mean position, acceleration is minimum acceleration, which is equal to 0 here. Now we consider the second one. At extreme position, at extreme position x equal to plus or minus a. Therefore, acceleration is equal to minus omega square into plus or minus a, and which is equal to, we get here, minus or plus a omega square. That means when your particle is at right extreme, x equal to plus a, we get here that is maximum acceleration is equal to minus a omega square. And when particle is at left extremity, we get here again maximum acceleration, and which is equal to a omega square. That means in this equation, if we put x equal to plus a, we get minus a omega square. That means acceleration directed towards left. And whenever we put in this equation x equal to minus a, we get maximum acceleration direction towards right, like that. I have shown here both. That means velocity, this is plus, and here velocity, this is minus, like that. Here plus sign and minus sign I have given designation, and this is all about, that is maximum and minimum velocity, maximum and minimum acceleration. I hope you all understand this. In next period, we consider here graphical representation of SHM, which is very much important. You study all these articles up to that time. Thank you.